You can perform operations on numbers that are written in scientific notation without having to expand them out into their full number. And so we're going to look at adding, subtracting, multiplying, and dividing when we have the numbers written in scientific notation. So the first one we are going to look at is adding and subtracting. If the exponents on the powers are the same, then you can add or subtract the bases. So for example, if I have a question like this, the powers on the 10 are the same. If we were to think about that in a place value chart, the numbers would look like this. So here I have my, on this side I would have my ones and my tens, my hundreds, and then I get my thousands, 10,000s, 100,000s column. And so when the powers are the same, the bases, these numbers here in front of the multiplication sign, are going to line up underneath of each other in the place value chart. And because they're in the same place in the place value chart, then we can just add or subtract those numbers and the powers kind of tag along. So what we end up doing is 4 plus 3, and then the times 10 to the power of 5 tags along. And so altogether we have 7 times 10 to the power of 5. The same thing happens with subtraction. If the powers of 10 are the same, then that means they are going to line up in our place value chart, and therefore we can just subtract the bases and the times 10 to the power of 6 tags along. However, if the exponents are not the same, we cannot just add the bases because they don't line up in our place value chart. And so we need to make the bases the same before we can add or subtract. So for example, if I have something like this where I have 4.2 times 10 to the power of 5 and 3.5 times 10 to the power of 4, and I'm adding them together, in the place value chart, it's going to look like this. The 3 is lined up in the 10 to the power of 4 column, but the 4 is in the 10 to the power of 5 column. So if I was just to add these numbers, I would be mistaking the position of this 3 and the 4, and I would end up adding the 4 and 3 together, even though they're not lined up in the place value chart. So what we need to do is make the powers the same by either making this number into a times 10 to the power of 4 or making this one into a times 10 to the power of 5. Doesn't matter which way you go as long as they're the same. I personally like to go and make the powers the same as the smaller power. So in this case, I'm just going to shift this 4 over, and so my number becomes 42 times 10 to the power of 4. So I've expanded one of those powers of 10 out, and now that my powers are the same, I can add those front numbers together. And then we always want to put the number back into proper scientific notation. So in this case, I'm going to move the decimal over one more spot. I'm going to divide by a power of 10 here so that I can get this to be a 4.55 times 10 to the power of 5. So I'm moving it back over to put it into proper scientific notation. Okay, so I'm going to expand it so that the powers are the same. Then I can add the bases, and then I need to put it into proper scientific notation. So I want you to try this one. This is a subtraction problem, but the process is the same. Pause the video, try it out, and then start it up again when you're ready. Okay, so again, because the powers are not the same, they're not going to line up in a place value chart, and so I need to make the powers the same. So I'm going to move that 5 over into the other column, and I get 56 times 10 to the power of 2 minus 2.4 times 10 to the power of 2. So I'm going to subtract those front numbers, the bases, and then I have to put it back into proper scientific notation, move that 5 back out, and I get 5.36 times 10 to the power of 3. When we're looking at multiplication, let's specifically look at the powers. So if I have something like 10 to the power of 3 times 10 to the power of 4, what this means is I have 3 tens being multiplied together, and then I'm multiplying that by 4 tens being multiplied together. So really all together, I have 7 tens being multiplied together. So if we're looking at the powers, what happens? They get added. And so when we're multiplying with powers, we can add the exponents. So let's look at this question. What I'm going to do is multiply the bases together, and then I'm going to add the exponents on the powers of 10. So that all together, I get 14.7 times 10 to the power of 9. And then as always, we need to make sure it's in proper scientific notation. So I'm going to move the decimal over one more, and I get 1.47 times 10 to the power of 10. When we divide powers, this is what it looks like. So if I have 10 to the power of 5, divide 10 to the power of 2, I get 5 tens multiplied together on the top, and then I'm dividing that by 2 on the bottom. And so the 2 on the bottom end up canceling 2 on the top, leaving me with 10 to the power of 3. So what's happening with our exponents? They're being subtracted. So when we divide with powers, we subtract the powers. So for example, if I have a question like this, I'm going to divide my bases and then subtract my powers of 10. And then we always want to make sure it's in proper scientific notation, and in this case it already is, and so I can leave it as 1.6 times 10 to the power of 2. Okay, here is one of each: an addition, a subtraction, a multiplication, and division. I want you to pause the video, try them out, and then start it up again when you're ready. So for my first one here, I'm going to make my powers the same. Either we can move this one over this way to make it a power of 4, or we can move this over 2 spaces to make this a power of 2. We then add the numbers and then put it back into proper scientific notation, and we end up with 3.562 times 10 to the power of 4. For number 2, we're going to either make this a power of 5 or this a power of 7. Subtract our front numbers and then put it back into proper scientific notation. We get 1.475 times 10 to the power of 7. For question number 3, I'm going to do 4.2 times 6.8 times 10 to the power of 8. We add our numbers and then we put it into proper scientific notation, and we get 2.856 times 10 to the power of 9. And finally, for number 4, I'm going to divide those front numbers and then do times 10 to the power of 5. I'm subtracting my powers. Make sure it's in proper scientific notation, and we get 1.6 times 10 to the power of 5.